This project develops a tool that can automatically generate a cabin interior monument FEM within less than a day. When a cabin interior monument such as a galley is designed and manufactured, you have to show that it's strong enough, that it can withstand the emergency landing cases. You also have to show that your structure is not overloading the aircraft frame, and the easiest way to do this is with a finite element model of FEM. This sort of work, because it's very logical and there are processes defining exactly what has to be done, this work's normally sent to low-cost overseas suppliers. This is an indication of how suitable it is for automation. If it can be packaged up to send to another supplier to do, it's an indication that can be automated. So that's why we've identified it and used it, and we have developed a tool to automate it. The tool will generate a FEM in minutes, but there's a lot of checking that happens, and our engineers here are approver level. So when we deliver the FEM, we can guarantee that it's going to make it through and be passed and acceptable to the customer. The tool is completely generic. It's not relying on customers' processes or naming conventions. It's using some AI and some really clever programming in there to identify the types of parts. It can tell a panel by its shape, by its size, by its materials, the extrusions, and combines these to form the FEM. Although this automation has been developed specifically for cabin interior monuments such as galleys, the processes that have been developed are already being expanded to be used in primary structure on the ribs and wherever finite element analysis is used. At Cabot, we work on loads of different projects, and we see opportunities to improve on most of the projects we work on. But because we're under strict program pressure, we don't have the opportunity to develop the sort of tools we want to. The funding from NATEP has allowed us to set up on our own separate project that we can use and not be reliant on a customer asking us to develop tools. So we've really got good opportunities to develop the sort of improvements that we want to and make a real difference. There was a big downturn in aerospace with the lockdown, and all of our projects were pulled apart from the NATEP jobs. So it's kept us going and allowed us to really focus on improving and getting the tools that we want developed to the standard that we want them. And in the future, we are going to have these tools that we can use to approach customers and show how we can make the processes that they do every day slowly work really quickly to a better standard and really improve the way that they're making their structure.